In the enterprise, we have been used to deploying Windows to Intel and AMD architectures for decades. Well, now there's a new architecture that is gaining serious traction: Windows on ARM. ARM is a different kind of processor architecture, one that is already dominating in smartphones and tablets, thanks to its energy efficiency and modern design. But now, it's coming into its own on laptops and PC, and Windows 11 is taking full advantage. We're now starting to see competitively priced ARM-based PCs from Microsoft, Lenovo, and others. However, if you're running an ARM-based device, you'll need a completely different version of Windows 11, Windows 11 on ARM. Now, this isn't the first time we've seen Windows running on an ARM device. Windows RT launched way back in 2012, but this wasn't well received at the time, partly due to it being based on Windows 8, but the main reason being that it was heavily locked down, and you couldn't run traditional x86-based applications. These drawbacks have been very much addressed in Windows 11 on ARM. So what exactly is Windows 11 on ARM? Well, in a superficial sense, it looks and behaves just like the Intel-based Windows 11. But this time, it's the same Windows 11 user experience that you already know. The same start menu, the same applications, the same productivity tools. But this time, running on a new class of device running ARM-based processors. The end-user experience of ARM Windows 11 is identical to Intel AMD. The compatibility issues between x86 and ARM applications have largely been addressed. Most software runs absolutely fine under emulation, all of which is completely transparent to the end user. Windows 11 on ARM is installed from completely different installation media, in the same way we used to use different media for 32-bit and 64-bit versions of Windows. However, for many IT departments, rolling out an entirely new architecture can create some deployment headaches, particularly if your deployment solution doesn't support ARM. You may have the hardware, but you're unable to deploy your usual Windows 11 corporate build onto it. Let's see how we can support ARM in the latest version of OneDeploy. Here, we can see an example of how we can use OneDeploy to create a build for your new ARM devices. First, we load the Windows installation media of the version of ARM that we want to deploy. In this example, we're using Windows 11 𝗦𝗽𝗀𝗀𝗃. Now that we've added our ARM OS, we can now create or edit an existing build to support ARM. Here, we're editing an existing Intel AMD build to now also include ARM. You can see that we can now support both architectures from the same build. Whilst it's perfectly possible to have two separate builds, one for Intel AMD and one for ARM, OneDeploy allows you to accommodate both from a single build. This can help reduce the number of builds that you need to maintain. And by using a single build, it's going to help with delivering a completely consistent user experience no matter what architecture you're deploying to. However, having created a build, it doesn't end there. It is important we can keep up to date with the latest hardware from both Intel AMD and ARM architectures. OneDeploy's driver library can now accommodate ARM drivers as well as Intel AMD, meaning you can keep adding support for new devices as they appear. And if you're an MSP, you can do all the work for adding a new model once and then have that support apply to all of your customer builds. However, there is one final thing we might want to do to ensure that we get the best out of our ARM hardware. Whilst Windows 11 on ARM has excellent emulation for apps written for Intel AMD, this emulation does add overhead. Native ARM applications can deliver significantly better performance, efficiency, and reliability than x86 apps running under emulation. Running native ARM apps means running applications that have been compiled specifically for the ARM architecture. These are usually installed from separate installation media. Using OneDeploy, we can configure our multi-architecture build we saw earlier to install the native ARM versions of applications when running the build on ARM devices. Here, we can see an application that has different installation steps depending on what architecture the build is running on. We tell OneDeploy to direct the installation steps to the ARM version of the install media where applicable, thereby ensuring our ARM-based devices are getting these natively written applications wherever they can. And all of this multi-architecture support is delivered from just a single OneDeploy build. Now we're ready to deploy some PCs. Now that we have our multi-architecture build, we can deploy to both of these devices. We have a Dell Pro 16 laptop based on an i5 Intel processor, and we have a Microsoft Surface laptop based on an ARM processor. Although they look like standard PC laptops, we know that these are very different underneath, and each of them require their own architecture-specific version of Windows in order to run. We're going to install our multi-architecture build to both devices. For the person doing the deployment, all of the architecture selections are completely automatic. You don't have to do anything different on either device. Here, we're network booting both devices, selecting our multi-architecture build for deployment, and OneDeploy does all the rest. Windows 11 ARM Edition will install to this laptop, and the traditional Windows 11 for Intel AMD will install on the Dell. They will both receive the same set of apps, with some of those application installs tailored towards a specific processor architecture where applicable. And we did all of this from a single build in OneDeploy. Same build, different architecture, identical user experience.
OneDeploy. Windows deployment reimagined.